FSD students, this is your first gold day, instructional day. Leaving off where we left off, we're going to cover expected value today. Our objective is going to be to find the expected value in situations that involve a gain and or loss and determine if a game is fair. By game being fair, meaning it's an even 50-50 deal. So expected value is defined, or to calculate it, you must multiply each gain or loss by its probability, and then add the product. So multiply each gain or loss by the probability, and then add the products. So for example, in a simple game, a player rolls a die. If the die shows a 1, 2, or 3, that player gains 10 points. If the die shows a 4 or 5, that player loses 13 points. If the die shows a 6, that player loses 1 point. So for example, I would begin all expected values with events, gain-loss, and probability. So for example, in this case, one event is a 1, 2, or 3. That gain-loss, that is a gain of 10 points. That probability is 3 out of 6, or 1/2. Another event would be the die showing a 4 or 5. They're going to lose 13 points. That probability is 2 out of 6, or 1/3. And the final event is showing a 6. That player is going to lose 1 point, and that probably is 1 out of 6. Now, without reducing, we might want to keep this as 3 out of 6 and 2 out of 6. And then by definition, we're going to multiply the gain-loss times the probability for each of these, and then add those. So this would be 30 out of 6 plus a negative 26 out of 6 plus 1 out of 6, or minus 1 out of 6. If you add these up, you get 3 out of 6, which is 1/2. And that is a positive 1/2. So the meaning of this is that for a player playing this game, each time, each roll of the die, they would be expected to gain a 1/2 point. So therefore, this game is in favor of the roller, the person who rolls the die. So once again, an expected value of 0.5 points means that if you were to play this game many times, your average gain per game would be 0.5 points, meaning the game is in your favor. Playing the game 100 times should result in a gain of about 100 times 0.5, or 50 points. If we had an expected value of 0, that would mean the game is a fair game in favor of neither the player nor the house. A negative expected value would mean the game is in favor of the other player or the house. Typically, in casinos, in any games that you play, at carnivals and so on, they would have a negative expected value because the casinos or the carnivals will win and the player will typically lose. Another example, calculate the expected value and determine if the game is fair. So a die is rolled, the number shows is odd. Player A wins $1 from player B. If it's a 6, A wins $2 from B, and otherwise B wins $3 from A. So again, I'm going to do this in terms of player A. So we're going to have our events, our gain-loss, our probability. One event here is the die being odd. If it's odd, player A wins $1. And the probability of it being odd is 1/2. But again, I'm not going to reduce that to make the multiplication easier. If it's a 6, player A wins $2 from B. That has a probability of 1 out of 6 of happening. Otherwise, B wins $3 from player A. So the other situations here would be a 2 or a 4. Player A would lose $3, and that probability is 2 out of 6. Now, once again, calculating this expected value, this would be 3 out of 6 plus 2 out of 6 minus 6 out of 6. Adding these would be a negative 1/6. Now, we did this in terms of player A, so therefore, this game is not in favor of player A, it's in favor of player B. If player A would roll the die, let's say 60 times, they would expect to lose $10, lose $1 for every 6 times they would play, or lose 1/6 of $1 each time they play the dice or roll the dice. Suppose you play a game in which you make a bet and then draw a card from a well-shuffled standard deck that includes 52 cards as well as the 2 jokers, so 54 cards. If you draw a joker, you keep your bet and win 5. If you draw a face card, you keep your bet and win 2. And if you draw on any other card, you lose your bet. What's the expected value if your bet is $1? So once again, I'm going to do events, gain-loss, probability. The events would be a joker, which is a gain of 5, has a probability of 2 out of 54. A face card, which has a gain of $2. A face card's probability, there are 12 face cards, so 12 out of 54. And then if you draw any other card, so taking the jokers and face cards, there are 14 of those. So your probability here would be 40 out of 54. And they would lose their bet of $1. Calculating this, it'd be 10 out of 54 plus 24 out of 54 minus 40 out of 54. So 34 minus 40 would be a negative 6 out of 54, which reduces to a negative 1/9. Once again, meaning each time a player would draw a card, they would expect to lose 1/9 of $1, about 11 cents for every time the game is played. If you play this 100 times, you'd expect to lose $11.